So I hear that there are some people in the room, I can't see you, so which is fine. So if you sleep, I won't be aware of it. That's okay. So welcome to the session, We Hate Code. And unfortunately, because I can't see anyone, I won't ask questions because I can't see the result of it, or the answers. First of all, we are in room 12, and here they use Slido. And if you would like to have, or if you have questions afterwards, then you please go to this URL or scan the QR code and then use the code GeeCON. And then you can put in your questions on room 12, and then if we have time in the end, I will try to answer them. Otherwise, I will be outside and you can come to me and I will try to answer. Then because I have 210 slides, new challenge. My name is Gerit Grunwald, I'm working for Azul. We do JVMs, and that should be it. If you would like to connect to me, just find me on LinkedIn. Shouldn't be that hard. Okay, first question, even when I can't see it, who loves to maintain code? I just guess that there are software developers in the room. And yeah, I don't like it, to be honest. And bad code, this is just a word. And there are different kinds of bad code, right? So, and there's not really a proper definition. So let me start with legacy code. And there's dead code, which could be sometimes the same. Let's take a look at legacy code first. So this is code that was, we know that, right? Was written for no longer supported operating systems or hardware or stuff like that. Cannot be tested automatically. Is no longer developed or maintained by the original maintainer or creator. Lacks documentation. In short, code you are afraid to touch. Right? Everybody knows that. You come into a project. If we have consultants in the room, I guess we have. So you come into a project, you have to integrate some code in another code base. You see the code, you see something, would like to refactor, and then someone says, don't touch it. Well, this, just keep it. Someone wrote it 10 years ago, it's still running, we have no idea what it does, but don't touch it, we don't want to break the system. So you just don't do it. So how to deal with it? Even that, we know there are solutions to do it, right? So there's refactoring, there's rewriting everything from scratch, which is valid, but not really used a lot. And you can also try to find out if it is used at all, which is probably the hardest part. Sounds easy, but it's not really. So refactoring, yeah, first of all, you have to understand the code. Should be obvious, but it's not always the case. If you worked in projects, for example, in Asia, as I did, find comments in Asian, some Chinese or Korean stuff, makes things not really better. You can make use of static code analysis tools. There's stuff like checkstyle, spotbugs, whatever, you name it. Lots of tools, you probably know them all and use them. The biggest problem is time, right? So if you go to your manager and say, I've found something, we could refactor it, make it better, then usually the answer is, yeah, that's a good idea. I would put it on the list. Create a Jira ticket, something like that. And it will stick there forever, right? So because there's never time to do that, usually. So if we go to rewrite, then it's even worse. Because if you have to rewrite, then first of all, you need to know the requirements of the code, right? And that sounds easy, but it's usually not. Because usually if you really make the decision to rewrite code, that means this is old code. It was created a long time ago, and sometimes nobody's in the company anymore who knows the original requirements. So it's not that easy to do that. And you need to know exactly what the code does to be able to rewrite it. In principle, it's like a new project, right? With all the work and all the cost involved. And then that means biggest problem, not only time, but also the money. Convince your manager to rewrite code. Well, there's not really a return on investment here at the first glance, right? Because it does the same as the old code, just it's new and we can maintain it, but if we don't touch it, it's all good, right? So the strategy often is just keep it running and fade it out slowly until we have something new, right? Okay, that leads me to dead code, which is, like I said, sometimes a part of legacy code. This is usually unused imports, variables, methods, and classes. or unreachable code, right? So redundant code, obsolete code, commented out code, and the risk of keeping it in your code base, because we all know that. I mean, I also created lots of libraries and stuff, and I always have code in there that I put in comments, just because I'm afraid to delete it, and it's so nice, I would like to keep it, maybe later on I can use it. Well, if you have this dead code lying around, then it's, first of all, it increases complexity. If you have a junior developer come into your team, working in a project, put him in front of the code and he reads all the stuff and try to understand, and he also reads the comments and all these things, and then later on you tell him, yeah, you don't have to, this is just stuff, it's in there. So how should he know? So it's really hard to get into these code bases, and it can reduce performance, of course. It can introduce bugs, right? Because if there's some code that is not really used, but can be used by something else, could be tricky, which means also security vulnerabilities might be, there might be open doors for some exploits, and code reviews will take longer because you also have to review all this stuff that is probably not really used. Well, the good thing is we have solutions for that, and something where people ask, okay, but where does it come from? There are some reasons, right? First of all, build now, fix later, we all know that. We have these deadlines, we have sprints, and then it's, yeah, we can do it better, but just do it, build it, and then we will fix it in the next sprint. That will never happen, right? But this is usually what happens. And hesitance to delete, I just guess that we have software developers in the room, so I really have a problem sometimes to delete my own code, even if I know it's in the repository and I can always get it back. It's like, looks so nice. It's such a great piece of code. I can't delete it. I don't need it yet, but maybe next week. So I keep it. And this, I'm not alone with that, I know that. I saw that in project when I worked as a consultant. You see these pieces of code, and when you ask the original developer, it's like, yeah, I know, we don't use it yet, but I heard something, we might use it next month. Okay, well, I just keep it. Then you left the project, the code stays in the code base, new people come, nobody knows, keep it. Just make sure you don't break it, right? Tests are all green, it's good. So we have problems with incomplete refactoring, so there might still be code in there because an older refactoring didn't really went through. Merging code branches, another problem. If you have similar functions in two different branches, you merge it. Tests are still green, but you might have duplicates, right? Which is not needed. And probably most of the times it's just lack of awareness. We have these huge projects, and there's not one person who can really take care about all this stuff. So it's normal that there is code that is not used in your code base. So removing that is, lucky us, easy, because we have solutions. Who's using IntelliJ? Now I try to see someone. Who's using NetBeans? Yeah, okay. Is Jaroslav not in the room? And who's using, for example, Eclipse or Visual Studio Code? Probably also some people. There are tools in these IDEs to find these pieces, right? So in IntelliJ, for example, if we have method 3, which is not used, then it will just tell you, okay, there's a method, it's not used, and you can remove it. Fine, even for variables and all these kind of things. But you already see the problem in a big code base that might help you in one class, but if you have to go through all of this stuff, it's really a lot of work. And usually you don't do it, right? Then there are other tools like SonarQube IDE, does more or less the same, more configurable, and this is free. I think it was called SonarLinker or SonarLink before, now it's SonarQube IDE. It's for free. It can do the same stuff, which is nice, but again, removing it, not so easy if you use it for your whole code base. But at least we have solutions to do that. But usually we are lazy and don't do it, right? So then there's Open Rewrite. Who knows Open Rewrite? This is fairly new still. It's a community-driven open source project, enables developers to effectively eliminate technical debt because they have an auto refactoring engine. And the interesting part is you can create recipes. They also provide recipes. There's a marketplace. And for example, there's a recipe to remove unused methods, right? Automatically, same code as before, method 3 is not used, and in your Maven file, for example, Gradle will look similar. In this case, you see the recipe name here. It's removed unused private methods, right? So you add that as a plugin, and then you can run mvn rewrite run, and in your code it will do this. So before that and after it, it's just removed the method from your code base. And it can do that in all classes. And then you can create a pull request, but be careful what you do. But still, this stuff is relatively safe to use. So this can help to remove all these things, right? So there are tools to do that, which is great, and it works. But there's another piece of code, and this is, I call it zombie code. And zombie code, it's the worst part of all this bad code stuff. Because this is code that you maintain. You probably have tests for it. The worst case is that the test is the only code that calls this code. That means the IDE won't find it. Also Open Rewrite won't find it, because it will be called by the test. Yeah, it's used, right? How do you know if this code is ever be executed in production? And when I heard that the first time, I was like, yeah, come on. It couldn't be that big of a problem. Well, if you have endpoints, REST endpoints, how do you know if the customer is really triggering these endpoints if you don't monitor it? And I know that not many companies do it. It's often feature-driven. You create new stuff, add it to your code base because it was requested, but then it's not monitored if it's really used and how long is it used. Especially if you have banks and insurance companies, they have these code bases that are really old, and there have been products in the past, and yeah, they have been in use in the beginning for quite some time, and then suddenly there was a replacement, and we just added in parallel, and now nobody knows. Yeah, this is in use and this is in use. Yeah, just keep it. And that's really, like I said, when I heard that, I was okay, that couldn't be a big deal. One thing, how to add this stuff, and you probably know that, you have this situation where you have to add something like a matrix multiplication in code, right? You have no idea how it works. You had that in your university time, but that's a long time ago. So you ask someone, another developer, and says, yeah, Apache Commons. There's a method in there. Cool. Just add it, right? Add it as a dependency. You use the one method that you need, and you add 16 classes and 224 methods, right? To use one of those. The rest is just unused. But you put it in your artifacts when you deploy it. And if you really think about it, then this is the code that it needs. Right? It's really not that complicated, but we are lazy and we are used to use dependencies all over the place. Take a look at your build script and check all the dependencies that you have in there. It's a lot. And then think about what you really use from that dependencies. I agree, you can't just remove it because you can't just remove Apache Commons, because you have first to know where it is used in your code base. Also not so easy to figure that out. So that means in this case it was just 2 methods that you need to add, but you add a lot more to your code base. And we have other difficulties. If you, for example, are a library or framework developer, you really have to think about before making a method public, because probably you will never be able to remove it again because you don't know who's using it, which is really tricky if you think about it, if you are in this situation, right? So you add code to your library because someone requested it, but for you it's probably impossible to measure if it is used at all because you don't have phone home or something in your library. Pretty hard. With AI-generated code, it can be even worse, because then you might not even be aware what code was added and made public, especially if you just do copy-paste. It works, you have a test, it's green, it's cool, It saves you time. Someone has to maintain that stuff later on, which is, could be really tricky. So the question is how to find this code that is maintained, that is somewhere out there, but you have no idea if it is used. So you can only do that in a running system. So there's no really a way to figure that out with static analysis tools, because like I said, it is used by a test, for example, right? So there's one method which is called tombstone logging, and it sounds a little bit like, really? But it works. If you use, for example, log4j, you can create custom log levels and you can make use of static initializers of classes. And then this would be, for example, a configuration for custom log levels in log4j. I have one for used class and one for used method, right? And so I add that in the static initializer of the class. This is the static function there, the block. I use the used class log method. That means every time I instantiate this class, this log method will be logged. And in the methods, if I have, for example, 4 methods, it's the same code as before, and I call only 3. And in these methods, I then have the log output. That looks like, yeah, this is really simple. You added a log output to all your methods and all your classes, and then afterwards you know what it is used. Right? But only what is used, not what is not used, right? But at least you would get an idea. And there are tools to add this stuff to your code base. So you could do that. And this would be, for example, the result afterwards, right? You see, oh, 1, 2, 4 was called, and the class was called, method 3 wasn't called. Okay, you now know the stuff that was called in your code. The same can be done by using flight recorder. You can create custom flight recorder events and then analyze them using mission control. I hope everybody knows what that is. If not, look it up. You can create a used class event or used method event, and then you just fire them in the same way where you log the log messages, right? Instead of doing logging, just fire these custom events, and then it will create a file where everything will be logged, and then afterwards you can use mission control to take a look at the results. It's just the same thing using different tools, right? So then you can see here, there was a class, the used class, and then we have these 3 used methods. That's all nice, right? Because we now have to figure out how to find the unused code, because that's the stuff that we might be able to remove from the code base. And for this, you can either use the ASM tools. I don't know if someone knows that. They are also used in OpenJDK. And before JDK 23, this have been used in OpenJDK, and from JDK 23 onwards, that means with JDK 25, which will be the next long-term support version this year in September, we have the class file API. And with the class file API, you can get information about, for example, a jar file, and it gives you all the classes and all the methods in that jar file. This is, you can write that thing in maybe 100 lines of code. It's not really a lot. Pretty simple. With both of the tools, it doesn't matter. And then you have to create a diff of all the code that you have against all the stuff that was used. And so you will find all the code that wasn't used, right? So but you see, it's a lot of work to do that. First, you have to create the log files. Then you have to create some kind of log parser that gives you all the information in a file in a format like this is the class, this is the method that has been used. Then you have to write something using either the ASM tools or the class file API to get the information from all your jar files, right? Then you have a list of all the classes and all the methods, and you have a list of all the used classes and methods, and then you create the diff, and then you have a report in the end that tells you this stuff wasn't called. This is just the technical part. The next step is you have to run that for some time. Think about banks and insurance companies. They have these jobs that just run once a year, right? Or every 6 months. So that means if you started directly after that run, let's say 2nd week of January, and you run it for 11 months, you won't trigger these methods that will be used in the first 2 weeks of January. So that means all this finding unused code is a long-term process. It's nothing that you can just do now and you get the result tomorrow. It will take probably a year or longer. Given the fact that you also develop further in that time, it's not that easy. Yeah, we had that already. So this stuff is possible, but a lot of work, right? If you use tombstone logging. Let's take a look at other solutions because there's more. There is, for example, GeeCON. Probably everybody knows that. There's Scavenger. I guess maybe someone heard of it, but I don't think so. Same for this combination open rewrite and intelligence cloud. Let's take a look into it. But first, I have to talk about Java agents because this is an essential part of the next 3 approaches to find unused code. So Java agents, if we have the JVM, then it's obviously not a black box. We have different parts in the JVM, right? We have the class loader subsystem, JVM memory, execution engine, and every JVM comes with an API. And with OpenJDK, it's called the instrumentation API. In OpenJ9, it's called the attach API. But it's in principle the same because they follow the same spec. So that means we have this API. And at runtime, you can talk to your running JVM and get information from the JVM. To do that, you use a Java agent, which is again a Java program that talks to this API and can collect information by, for example, setting up callbacks into these systems. Let's say we are interested in the class loader system because we would like to know every time a class was loaded. So we hook up something like a listener to the class loader subsystem, and every time the JVM loads a class, it will trigger the agent and tell him, oh, this is the class I loaded. Then the agent can log this stuff in the background. This is in principle very simplified version of how it works. It's obviously more complex, and you can really mess it up with the Java agents because usually Java agents make use of a lot of code from the JVM. So they really try to get as much information as possible. And that can bring down performance because that happens at runtime. So the JVM not only has to run your code, but it also has to serve the agent all the time with data. And that can bring down performance. So you have to be careful with agents. But so if we take a look at GeeCON, which was made for Java code coverage, it's a free tool to report code coverage, right? Then it collects coverage metrics through a Java agent when the class loader loads classes. So in principle, what I showed you before. And this is usually used in development because this agent will also collect more information and it can bring down performance. But you can use it to detect dead code. Some smart people figured that out. And if you would like to find zombie code with GeeCON, then it works like this. So you have a jar file, and then you run it in your JVM, you attach the agent, the GeeCON agent, and you have to configure it in a way that it only monitors specific packages, so not all the packages, because otherwise it will really bring down performance. So usually if you have a Spring Boot application, it doesn't make sense to monitor Spring packages because you can't change them, right? You can't remove them. Instead, you just add your packages from your own software because there you can do changes. So then you run GeeCON and you run it for some time, right? Because you really need time to get all the information. And then you use the GeeCON command line interface to get this data and put it into GeeCON, and then it will create a data file out of it. So now we have the data of the used classes, and then now we provide using again the CLI of GeeCON to provide all the classes and all the methods, right? So this a process of how to do that, and then GeeCON can create a report, and then you can manually remove code from that report. So this is in principle the process, just the idea of it. And there are two different blog posts. I just give you one of them because the other one is the base for this one. So there's a company in the Netherlands called Picnic, and they have a blog post here where they show how they use Jacoco to find this zombie code in their code base, right? And I think they use it with Kubernetes, so they show you how to do that with microservices. And they refer to another blog post where it was used for a monolith, right? Because this is also still in use, this stuff, and it might be useful to take a look at that. As far as I know, they provide a complete blog post with a complete procedure on how to find that code. That's one approach. Then the next one is called a scavenger. And that's a tool that was specifically made to find that code, right? And analyzes runtime code with no code changes, and then can store the data in a MySQL, Vitis, or H2 database, and provides a web interface afterwards with the report. And the procedure here is very similar. You will see this is always the same stuff. So you can run it in multiple instances. And you run your jars in your JVM. You attach the agent. And then the agent will call a so-called collector in this case, which is another jar that is running. Let's say if you have your cluster, then all the agents talk to this one collector. And then the collector takes care about saving the stuff into the database. That's the idea here. And then again, you run it for some time, and afterwards you get a report, which is a website. Well, this is in principle a very nice idea. The problem with this is, first of all, what you get, before I forget that, you get the ability to find used and unused code because it was made for that. And you can create so-called snapshots at any time. So you don't have to wait for 6 months. You can also, after a day or after 2, you can create just snapshots and then analyze the report in this web interface. And you get method level resolution. So you get really this class and this method was used and this was not used, which is exactly what you would like to see. Because in the JVM, the smallest, let's say, unit the JVM is working on when it comes to this kind of stuff is methods, right? So the drawbacks with this tool, I tried to set it up and I got Korean dialogues, which is unfortunate because I'm not fluent in Korean. And then I thought, okay, let's take a look at the code. And yeah, it wasn't very descriptive. And also the documentation is just the GitHub repository. So I wasn't able to really get it running. So everything I showed you is just from the GitHub repository, what they say what you can do. So there's no proof. You need an accessible database, of course. Yeah, there's really a lack of documentation for this product. And then you also have to create an API key with every time you start it. So that means if you started in a cluster, then you started on one node, you need to create an API key. Then on a second node, you need to create an API key, which makes it really hard later on to figure out what is exactly the state of the application that I monitored. Just keep in mind, you have continuous development usually and deployment. So that means in January you have version 1, February version 2, version 3, and so on. If you just started with this generated API keys, how do you know which key was used for which version? Right? It's a little bit tricky. So it can be useful for smaller stuff if it works. But yeah, it wasn't also not very stable. So like I said, I didn't really get it running on my machine. I tried it a couple of times, but yeah, it didn't really start. Okay, you can find it here, github.com, Navier Scavenger. And this is also based on a former tool that had a different name. So I don't know, but you will find information about that one. Okay, that is Scavenger. Nice idea. Like I said, drawbacks with both of these tools. Once you get the report, you have to go through this code and remove it manually. And yeah, you can do that. And the people at Picnic, they do it. But a story that I can tell you is we have a customer, and this customer is a big one, and they ran another tool to figure out that code, and they figured out they have 70% of their code base wasn't used in production, which is really a lot. So I couldn't believe it, and we thought about telling them the truth or just telling them, yeah, it was around 50%, because 70 is really a lot of code that is not used. So if you have to remove 70% of your code manually, it takes a long time. So this brought us to this combination, which is Open Rewrite, and we saw what you can do with Open Rewrite, right? So you can automatically remove code from your code base. And Intelligence Cloud is something that we invented at Azure, which is very much the same that we saw with Scavenger, very similar. But we didn't know about Scavenger when we created it. We saw it afterwards. So this was driven by customer requests. So it's a cloud service that collects data from JVMs, whatever. It could be OpenJDK, could be OpenJ9. And we also use an agent. It's pretty much the same approach. You get the information about used and unused methods. And if we find zombie code, then instead of using just one, you can run multiple jars in your cluster, for example. And now the difference to Scavenger is instead of using randomly generated API keys that they need to do, we run the agents and then we can create tags. So that means if you use if you have continuous deployment, you can just, when you start it, add a tag. This is version 1, right? And if you really use proper tagging techniques, then you can do something like my app v1, and afterwards, later on, if you have my app v2, v3, or whatever, you can filter and say, give me everything that starts with my app v. Then you get all the versions over the complete time frame, right? And you can run it in different architectures, so it could be different JVMs, different architectures, so it doesn't matter because the agents then talk to, we name it forwarder, that was the collector in Scavenger. This is something that the customer installed somewhere in the infrastructure, and then all the agents talk to this one, and then the forwarder forwards the information to Intelligence Cloud where everything is stored and analyzed later on. So then you have to run it, as with all the tools, for, let's say, 6 months, and then you can do a report. You can also do a report after a week, like with all the other tools, and then you can either check it in the web interface, and you can see a report looks like this. It's not really that important, but you see we have classes, methods, used, unused, and then we can also tell you when it was called the first time and the last time. And our agent is like the one with Scavenger made just for this. So the performance overhead is around 0.2%, so it's nothing. At runtime, it doesn't really have a big impact. That's nice, but it also comes with an API, so that means you can write your own tool and get the information. Because sometimes such a report is nice, but you would like to have something different. So I created my own tool, which is a JavaFX application, of course. And that looks like this because I'm more used to this tree view structure, right? Because we see that in IDEs. So you have your jar files, then you see the packages, and you see the usage in each package. Right? So I can even click on something like a class and then get information about all the use classes, inner classes, and all these things, which is, yes, it is helpful, but again, it only gives me the info, and then I have to remove it manually. So this is nice if you have an API, because we added this to make it possible to integrate it in tools, for example, like IntelliJ or whatever. But the real interesting part is because it has the API, and if we combine it with Open Rewrite, then Open Rewrite has a recipe since this week where they can access the API, and then they do the analysis on their side. And in the first step, let's say after 6 months, they can tell you, okay, these methods have been called or not called, and they can add deprecated annotations to the code. Instead of removing it directly, they can mark it in your code base, which is the first step. Because they know after 6 months, there might still be code that will be used in the future, right? So they mark it with this add deprecated annotation, which is available, I think, since JDK 9. And then you have something like for removal equals false. And you can add some string, like code inventory with a date or whatever. So then you continue running, let's say another 6 months, and then you run again the analysis in Open Rewrite. And what they can do now is if there was code that was deprecated before and was called in the meantime, they can remove the annotation again. If it's still not used, they can change the for removal to true, right? If it's needed, right? So stuff like that. And then you can run this step as often as you like, right? The idea is this really depends on where you're working. So if you have these jobs that run just once a year, make sure that it runs over this period where these jobs run. But this is domain knowledge, right? So this is something that only you know. So we don't know. So it's just possible to run this step a couple of times. Right? And then in the end, there's this final step where you say, okay, now we ran it for, I don't know, 1.5 years. We are sure that everything that is annotated with deprecated for removal true, then we can automatically remove the code from your code base that was deprecated. And then you have a merge request that you can, and you should really look through it very carefully, and then it will automatically remove all the code for you, and it's done, right? So the challenges with this are definitely continuous deployments, right? Because we have companies that deploy daily, so you have to find a way to make sure that this code that is deployed today and tomorrow and so on, that you can track it somehow. And that's what I mentioned already. So you have these different versions and you tag it, like in this case with v1.1, 1.2 and so on. And then later on you filter just for app v1 dot, right? And then you get all the versions and then you can figure out what was changed or what has changed over the time. All right. So this can be solved. Like I said, the final merge request with the removals, that you need a very good review for that one, because that really means the code is gone, right? It's still in your repository though, so you can get it back. Another problem is code that may be needed in the future. So I always thought if you do new developments, you do it in a feature branch. Once this is done, you merge it into main and then you deploy it to production. But I learned that there are companies, they always deploy to production, even the features, even if they're not finished yet. That means there is code in your code base that is not called yet, because it will be called when the feature is implemented. And if you stumble upon that one, there is not really a good solution for that. You need domain knowledge, you need people that really know about that stuff, because otherwise it will be removed, right? So there might be ways, and like I said, this is just, we started this week, so there might be ways in Open Rewrite where we can maybe define these kind of things or flag stuff, I don't know yet. But this is probably something that might be problematic. So what you get, yeah, you get the used and unused methods and classes. You can get the reports whenever you like. So you can even afterwards say, give me all the used code in this month, or from here to there, or whatever. So used and unused. You can have multiple JVMs. You have the API. Yeah, annotation, remove unused code automatically. More info can be found here on our website. But the next thing that is really interesting is the costs that are related to bad code, to all these different things that we saw, like legacy code, dead code, zombie code. If we say this is dead code, what is the cost involved in that stuff? So there's a study that I found, it's I think from 2020, so it's not really the up-to-date one, but still interesting numbers. So if you deal with bad code 4 hours a week, then it equates to $85 billion annually, right? And you can already tell this is a US study because it's huge numbers, and the US people love huge numbers, especially managers. So you can take a look at this study here. It's quite interesting. There's more information about all this dead code stuff in there. And as I said, it's not the latest and greatest, but it's still not too bad. There's another one, which is, I think it's a PhD thesis, where the guy figured out 100,000 lines of code results in $361,000 technical debt a year. And that goes in the same direction. And I think, I'm not sure if this is still available right now, because I think you have to pay for it at the moment. It will be made publicly available next year, as far as I know. But the link is there. That's all good, yeah, this is big numbers, but maybe a little bit too abstract, right? Because if, yeah, okay, it's $361,000 a year. Okay, cool. Doesn't really help me with my project, right? Or with my product. So to make it easier, because there are more studies, they figured out it's around $2 to $5 per line of bad code per year. And if you just assume you have your code is around 1 million lines of code, which is not unusual, right? And we just assume we have 30% of bad code, including all the different things that we saw. It's roughly around 300,000 lines of code, and that leads to 600,000 up to $1.5 million a year for your company that you could save if you really would use that. And you would not only save money, but you would save time. And if you save time, then it gives you time to work on other stuff, right? So it's really not that unimportant. And the conclusion of that all is that zombie code especially is real. I wasn't really sure when we started that project because it was driven by a customer, as I said. I think I can say it was Netflix. They had a different use case. As far as I know, it's stuff like if you have, for example, dependencies, and the thing that I mentioned with the matrix multiplication. If you have services and all the developers add dependencies and just use one or two methods, then after all, your service, your artifact gets quite big just because of the dependencies. And if you have to scale up fast and you need lots of instances, then deployment suddenly becomes an issue. Because if you have to always deploy and upload stuff, then smaller is better and it's cheaper. You can save money. So you would like to know, do we really need all that dependencies? And this is something that helps you to find that. Monitoring takes time and can come with complications, as we saw. So this is really a long time process, which might make it hard to tell to your managers that it might make sense. Because if you tell them, oh, it might need a year or 1.5, then it's probably like, will I be here in 1.5 years still? I don't know, right? So it's this might be hard, but this is the way it takes, the time it takes. GeeCON, Scavenger, or Intelligence Cloud can help with this stuff. Removing code often needs domain knowledge. So this is nothing that can be done by just only the developers. You need people that coming from the domain and tell you, yeah, that might be true, but there is a process that runs every 2 years. Then you have to be aware of that stuff, right? So this is things you have to clarify up front before you start that stuff. And bad code in general can really be a cost factor. So we figured that out with a couple of customers in the meantime, that it's really amazing how much dead code is lying around and is not used, but it produces cost by maintenance, right? You shift it from every JDK to the next one, make sure it works, you fix all the tests without knowing if it's really used. So with that, I would like to say thank you. We have still 7 minutes left, and now I will switch to Slido. Let's see if that works, if we have questions. We have some. What are the options for automatically re-trigger the pipeline on failure? I'm not sure what that means. Is this really related to this topic? Oh yes, good idea. Thanks. No internet. Wow, cool. That's pretty cool. And I don't have internet here. Okay, so if we have questions in the room, right? So we have, that takes too long. If we have questions, just shell it and I try to answer. Is there any question?
What did you tell the 70% customer again?
I'm not allowed to tell you the customer. What we tell them, we told them it's 70%. It was more than 70, it was 72. And they really didn't believe us when we told them. And then we showed them the log files and they said, this is, what would you expect when I tell you your code, 70% of your code is not used in production? That was really shocking for them because that's a lot of code. And I can tell you it's a big customer. And that was just the beginning of this whole thing, because then we learned, oh, okay, these customers have these problems. There might be more. And I wrote this little tool that I showed you, the client, right? The JavaFX stuff, just to run this demo. And even in this code, only 37% of the code was used, because I monitored this application when I used it. And then I figured out, oh, okay, this, even in my own code that I wrote for this demo, which is really just small, I only used around 40%. The rest is just lying around. I agree, I have libraries where I have code in there where I know that I don't use it for this demo. But it gives you an idea how much code you have in your code base that is literally not used at all. And some of this code can be removed. It's not all of them. Like I said, if you have a Spring Boot application, and I know most of the people work with Spring these days, this framework is huge. And there's probably lots of stuff that you can't just remove because it's in this framework. The same goes with libraries. If you have libraries that you really need, you can't just remove the library. But sometimes, if it's open source, right, you have to take a look at the open source license. It might make sense to just copy this specific method out of the library into your code base and just get rid of the dependency. Because if it's just one or two methods, then you don't really need the whole thing. But usually we are too lazy as a developers, right? So we just say, yeah, I just add it as a dependency and I'm done because then I can continue my work. But that leads to this whole stacking up or piling up of unused code. Any other question? Sorry, I can't see you. It's so bright. The annotation? What was the question? Oh, this is done. The annotation itself, the deprecated annotation, was added to the JDK in JDK 9, and we just use it. And this is done by the Open Rewrite recipe. So they exactly. Yes, the Open Rewrite reads the report that we provide via the API, find all the unused methods, and then they annotate it in your code. So you can find it and see, oh, this was annotated by Open Rewrite as a deprecated method. And like I said, they can even change the annotation. If you run it after 6 months again and the method was used in the meantime, they will remove it again. And if it wasn't, they can change within the annotation. There's this for removal equals true false. They can change that flag too. So that's why I said it needs time. Sometimes you have to run it, I don't know, 1.5 years, probably. It depends on the code base, to make sure that you really only mark the stuff that is really not used in that time frame. Any other question?
You can write an approach with the that called if and switch statement.
How would you do that? You have to add if statements everywhere, right? To make sure that it's used? Or what do you mean?
If you have logic,
Mm-hmm.
that has logic branches like in switch, how you detect that code in there?
Oh, this is not that hard because, as I said, the JVM keeps track of all this stuff. And that's why we use the agent. We started with this project by adding the logic in the JVM itself. So our JVM also can do it because we have the information what code is used and what is not used. The JVM knows it, right? But the problem was that we can't force people to use our own JVM. So we created the agent which does exactly the same with the same or less overhead. And so we can monitor exactly, because the JVM knows exactly which class was loaded, which method in the class was loaded. And we can make the diff because we use the class file API to do that. And you will get this information from switches and all that. Because this is always part of a method somewhere, right? So you can't get in the method. So you can't get stuff like, is this variable used? But this stuff can be done by, for example, IntelliJ, at least in your code base. They will find the stuff that is really not called. But they can't tell you the methods that are not used, right, in production. Anything else?
What about related stuff, such as Swagger, if you have it embedded in your code base?
Yeah, that's exactly these problems, right? Because Swagger you don't use in production usually, right? Because you create it once and then you have the website. This is stuff where you need domain knowledge. This is what I mean. You can't just remove it simply because there might always be things that will be used once, but not in production, or maybe not in a regular base. And if you don't know that, you will remove things that will break the code later on. So it's not an easy task, right? So it's not just press button and you're done. It's work involved, but we just figured out it's worth it because it's really a lot of money behind the whole thing. So I think we are running out of time. We have 40 seconds left. So if there's anything else, just find me outside, and thanks for attending. Enjoy the rest of the conference.